After the death of his old friend, Albert Einstein said, "Now Besso has departed from this strange world a little ahead of me." That means nothing. People like us know that the distinction between past, present and future is only a stubbornly persistent illusion. New evidence continues to suggest that Einstein was right, death is an illusion. Our classical way of thinking is based on the belief that the world has an objective observer-independent existence. But a long list of experiments shows just the opposite. We think life is just the activity of carbon and an admixture of molecules. We live a while and then rot into the ground. We believe in death because we've been taught we die. Also, of course, because we associate ourselves with our body and we know bodies die. End of story. But biocentrism, a new theory of everything, tells us death may not be the terminal event we think. Amazingly, if you add life and consciousness to the equation, you can explain some of the biggest puzzles of science. For instance, it becomes clear why space and time, and even the properties of matter itself, depend on the observer. It also becomes clear why the laws, forces, and constants of the universe appear to be exquisitely fine-tuned for the existence of life. Until we recognize the universe in our heads, attempts to understand reality will remain a road to nowhere. Consider the weather outside. You see a blue sky, but the cells in your brain could be changed so the sky looks green or red. In fact, with a little genetic engineering we could probably make everything that is red vibrate or make a noise, or even make you want to have sex, as it does with some birds. You think it's bright out, but your brain circuits could be changed, so it looks dark out. You think it feels hot and humid, but to a tropical frog it would feel cold and dry. This logic applies to virtually everything. Bottom line, what you see could not be present without your consciousness. In truth, you can't see anything through the bone that surrounds your brain. Your eyes are not portals to the world. Everything you see and experience right now, even your body, is a whirl of information occurring in your mind. According to biocentrism, space and time aren't the hard, cold objects we think. Wave your hand through the air. If you take everything away, what's left? Nothing. The same thing applies for time. Space and time are simply the tools for putting everything together. Consider the famous two-slit experiment. When scientists watch a particle pass through two slits in a barrier, the particle behaves like a bullet and goes through one slit or the other. But if you don't watch, it acts like a wave and can go through both slits at the same time. So how can a particle change its behavior depending on whether you watch it or not? The answer is simple: reality is a process that involves your consciousness. Or consider Heisenberg's famous uncertainty principle. If there is really a world out there with particles just bouncing around, then we should be able to measure all their properties. But you can't. For instance, a particle's exact location and momentum can't be known at the same time. So why should it matter to a particle what you decide to measure? And how can pairs of entangled particles be instantaneously connected on opposite sides of the galaxy, as if space and time don't exist? Again, the answer is simple: because they're not just out there. Space and time are simply tools of our mind. Death doesn't exist in a timeless, spaceless world. Immortality doesn't mean a perpetual existence in time, but resides outside of time altogether. Our linear way of thinking about time is also inconsistent with another series of recent experiments. In 2002, scientists showed that particles of light, photons, knew in advance what their distant twins would do in the future. They tested the communication between pairs of photons. They let one photon finish its journey. It had to decide whether to be either a wave or a particle. Researchers stretched the distance the other photon took to reach its own detector. However, they could add a scrambler to prevent it from collapsing into a particle. Somehow, the first particle knew what the researcher was going to do before it happened, and across distances instantaneously, as if there were no space or time between them. They decide not to become particles before their twin even encounters the scrambler. It doesn't matter how we set up the experiment. Our mind and its knowledge is the only thing that determines how they behave. Experiments consistently confirm these observer-dependent effects. Bizarre? Consider another experiment that was recently published in the prestigious scientific journal Science, Jacques et al., 315, 966, 2007. Scientists in France shot photons into an apparatus and showed that what they did could retroactively change something that had already happened in the past. As the photons passed a fork in the apparatus, they had to decide whether to behave like particles or waves when they hit a beam splitter. Later on, well after the photons passed the fork, the experimenter could randomly switch a second beam splitter on and off. It turns out that what the observer decided at that point determined what the particle actually did at the fork in the past. At that moment, the experimenter chose his past. Of course, we live in the same world. But critics claim this behavior is limited to the microscopic world. But this two-world view, that is, one set of physical laws for small objects and another for the rest of the universe including us, has no basis in reason and is being challenged in laboratories around the world. A couple years ago, researchers published a paper in Nature, Jost et al., 459, 683, 2009, showing that quantum behavior extends into the everyday realm. Pairs of vibrating ions were coaxed to entangle, so their physical properties remained bound together when separated by large distances. Spooky action at a distance, as Einstein put it. Other experiments with huge molecules called buckyballs also show that quantum reality extends beyond the microscopic world. And in 2005, KHC03 crystals exhibited entanglement ridges 1/2 inch high, quantum behavior nudging into the ordinary world of human-scale objects. We generally reject the multiple universes of Star Trek as fiction, but it turns out there is more than a morsel of scientific truth to this popular genre. One well-known aspect of quantum physics is that observations can't be predicted absolutely. Instead, there is a range of possible observations, each with a different probability. One mainstream explanation, the many worlds interpretation, states that each of these possible observations corresponds to a different universe, the multiverse. There are an infinite number of universes, and everything that could possibly happen occurs in some universe. Death does not exist in any real sense in these scenarios. All possible universes exist simultaneously, regardless of what happens in any of them. Life is an adventure that transcends our ordinary linear way of thinking. When we die, we do so not in the random billiard ball matrix, but in the inescapable life matrix. Life has a non-linear dimensionality. It's like a perennial flower that returns to bloom in the multiverse. The influences of the senses, said Ralph Waldo Emerson, has in most men overpowered the mind to the degree that the walls of space and time have come to look solid, real, and insurmountable. And to speak with levity of these limits in the world is the sign of insanity. If you liked it, don't forget to subscribe to our free Terra X channel.